Hi there, guys. The video is brought to you by FAML. Welcome to QA by Kamal. Okay, so the first derivation we would do is the number of ways, finding the number of ways of writing a number as a product of two co-primes. So needs to be determined why is it so? Why is it so? So let's discuss the general formula first. N, a number n can be taken as form in the form of a to the power p, b to the power q, and c to the power r. Okay, so where ABC are co-prime, and this is the prime factor representation of a number. So we can take a number like 12. 12, let's take 12, or for the sake of easiness, let's take 2 into 3. N can be taken as 2 into 3. Okay, this is an example. So n can be taken as 2 into 3. Therefore, 2 into 3. This can be written into two ways in the form of multiplication of the prime factors. So we have 2 and 3 as prime factors, and there will be another number 1. So 1 into 6 can be written as to 1 into 6. The number can be written as a product of prime two co-primes, and 2 into 3 is another way in which we can write it as a product of two co-primes. So we have two ways here in which we can write it like that. So let's move ahead. Let's move ahead. What if we get another number into it? What if we get another number into it? That would be, let's take another number. I'll change the color here. I'll change the color here. It's red. Okay. Let's take another number. Another number can be taken as 1 into 2 into 3 into 5. Okay. So how will we come up with the number of co-primes? First, we can choose one numbers and rest two numbers can be in other group. So we can group these two numbers or these two numbers, or so one number would be left in each case. So we can do what? 2 into 3 into 5, 3 into 5 into 2, and 5 into 3 into 2. So we can take, let me represent it. Let's take green. Let me represent it. So what can we do? Okay. So what can we do? Here is the number 2 into 3 into 5 can be taken as, and 3 into 2 into 5 can be taken as another such representation, and 5 into 2 into 3 can be taken as another such representation. So we can choose one each at a time, and these would be three ways, correct? Now let's take another example. Let's take two numbers at a time, two numbers at a time. So two numbers at a time, taking two numbers at a time, that will represent the same representation as we have done in this previous area, right? So we have three ways, and we would have another way of writing it as 1 into 2 into 3 into 5, correct? So total 3 plus 1, 3 plus 1, 3 plus 1, 3 plus 1 ways we are getting after it. After doing this, so we have total 4 ways of representing it as a product of 4 numbers, as a product of 2 co-primes. Okay, so let's increase a number. Let's increase another number. That is, let's increase another number. We'll take a blue pen. Okay, let's take a black pen. Uh, okay. So what will we do? What will we do next? Let's increase another number. So 2 into 3 into 5 into 7. All are co-primes, right? All are co-primes. All are co-primes. So we can take one number at a time and three numbers along with them. So that can be done in how many ways? Taking three numbers together. Numbers together. Okay. Taking three numbers together, we can take one number as another entity and these three numbers as another entity. We can do that in how many ways? We can do that in four ways. Four ways, right? And taking two number at a time. So we can do here by the combination method. Those for those of you who know the combination method, those of you who know combination method, we can take 2 and 2. So we can do that in 4C2 ways. That is a formula for factorial upon 2 factorial into 2 factorial. That would come up as 4 into 3 into 2 into 1 and 2 into 1 into 2 into 1. That will come up as 6 ways. But there is a catch here. There is a catch here. If we take 6 ways of choosing two numbers, another two numbers would be chosen automatically. And if we write it as the numbers, we will see that I will take the green color here. We will see that 3 into 5 into 7 into 2, okay, and 5 into 2 into 3 into 7, okay, 3 into 2 into 5 into 7. So that is a way of representation. But if we take another number, these two are in groups. Okay, let's take another number. If we take another two, all the if you notice in this, all the groups with 5 have been taken. 5 has been taken with 3, 7, and 2. So there are no other possibilities. No other possibilities. So we have only three ways to represent it. Right? We have only three ways to represent it. That would be 6 by 2. Number of ways would be divided by 2 because we are choosing two numbers and two numbers are automatically chosen. So we won't need to choose those numbers, two numbers. So 6 by 2, three ways will come out after that. Okay, so 3 plus 4. 3 plus 4, and we can represent it as uh, 1 into 2 into 3 into 5 into 7, taking 2 into 3 into 5 into 7 as a group. So we can represent it as one more number. So 3, 4, 1, 4 plus 1, 5, 8. 8 ways are the total number of representation. Hope you must have got it till here. So what will we do? What will we do? What will we do? We will do something like that. Okay. Let's say the general formula of two entities gave us two ways. Okay. The general formula of taking three entities gave us four ways, correct? And the general formula of taking four entities gave us eight ways. So what are we seeing here? It is equal to 2 to the power 2 minus 1. It is equal to 2 to the power 3 minus 1. 2 to the power 4 minus 1. Oh, sorry. The power needs to be subtracted. So 2 to the power 4 minus 1. What else do we need? What else do we need? So the general formula of a number which can be represented by, just let's take another color for that. The general formula of a number which can be represented by n is equal to a to the power p, b to the power q, c to the power r can be taken as, can be said that it can be represented as co-primes in 1, 2, 3. These are co-prime numbers and prime factors. Number of prime factors minus 1. So that is our formula. Let's check it after taking an example. So I will take a blank. So what can we take? Let's take a number n is equals to 12. 12 can be written as 2 square into 3. So what would be the formula? 2 and 3 are the prime factors, only prime factors. So the formula for writing n as a number of n is equal to 12 as a product of two co-prime factors would be 2 to the power 2 minus 1, that is 2. How can we write it? So we can write it as 4 into 3 and 1 into 12. So we are getting two ways. Hope you must have got it till now. Okay, let's move to the next page. Now, what will we be doing? So number of co-primes to n that are less than n. Nobody teaches you the formula. Let me increase the size of the. Okay. So nobody teaches you what's the derivation of this formula. So we will take some permutation combination lessons here. Uh, okay. So we have discussed that we can have number n, sorry for the delay, number n, number n, okay, number n, which can be represented as a to the power b, okay, c to the power b to the power q, and c to the power r. So let's represent the number as 48. 48 will be the number. 48 will be the number. So it can be represented as 2 to the power 4 into 3. Okay, 3 to the power 1. So that is the representation, right? So how will we get all the co-primes that are not divisible by the factors of 48? That is what we are trying to say here. Okay, let's move ahead. I will take another thing here. Okay, let's take two concepts here. Concepts we will include concepts we will include are concepts we will include are the concepts we will include are the permutation combination concept. Okay, permutation combination concept. What does it say? PMC concept says that whenever we take two conditions that are being applied in the same case, let's say we are taking uh, we are flipping a coin and rolling a dice. So the and condition would be represented as multiply sign. That is what we represent in permutation and combination. So what will we do next? We will see that 2 to the power 4 into 3 is the number, right? So we have 3 and 2 as are prime factors. So every number which is divisible by this number will be a factor of 48 or not co-prime of 48, not co-prime to 48 because it will have 2 as its common factor. And this number 3, we can say that every number divisible by 3 would be a prime factor. I mean, would have a common factor with 48. So what we need to observe is that one out of every two numbers would not be divisible by 48, would not have a common factor with 48, right? And we are using and PNC concept, and is what? Multiply sign. So every two numbers out of three numbers is not divisible by 3, right? Every one out of two numbers is not divisible by 2. Are we clear on that? So what we will take up till 48, what conditions are satisfied by these two conditions? So this is our formula of 548. Got it? We can do it easily. So 12 numbers would come, 12 numbers, sorry, 16 numbers would come which are not having factors common with 48. Okay, 16 numbers are there. Okay, let's move ahead. Let's move ahead. What are the numbers that will be co-prime factors of 48? Okay, 548. So this is called a Euler's formula. Euler's formula. This is also used in getting the number of sums which are below a number. The number of sum of co-primes, cofactor, co-primes that are below a number. I will discuss that question later in the series. So 548. 548 will have 2 and 3 won't be included. 5, 7, 11, 19, 23, 29, and 31. 33 won't be included. 35 won't be included. 37 won't be included. 41 will be included. 43 will be included. 47 will be included. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have got 11 numbers here. So you can also take other numbers like 5 into 5, 25, and 5 into 3, 15 won't be counted, 5 into 2 won't be counted, 5 into 6 won't be counted, 5 into 7 will be counted. Okay, 5 into 7 we have got, okay, 5 into 8, 5 into 9, 5 into 9 won't be counted, 50 would increase, 50 would get past the number 14. So what we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have completed 13 numbers. Let's look at the numbers which are the multiple of 7. 7, 3 won't come, 7, 4 won't come, 7, 5 we have taken here, 7, 6, 7, 7, 49. So what are we getting? What are we getting? 9 would have, we are missing some numbers. Okay, we haven't taken 13. 13. And is there any other number? 17 we haven't taken. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 numbers we have taken. 15 numbers we have taken. And 1 will also be included here. Right? So we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 numbers as the co-prime, and we thus prove the number of formula can be found out by this, right? Now we would go to the next concept. Next concept is sum of the co-primes of n that are less than n. Let's take a number. I will take the okay. Let's take the number is in form of a to the power p, b to the power q, and c to the power r. Okay. Now we can take a number as 48. 48. I would take 48. I would take a shorter number. I will take a shorter number. 2 into 3 into 2. Let's take 12. Okay. Let's take 12. That can be represented as 2 to the power square into 3 to the power 12. 4, 3 to 12. Yes. 2 to the power. Okay. So Uh, what are the co-primes to this number? The co-primes to this number would be 5, 7, 11, and 1. Right? 5, 7, 11, and 1. So what are we getting? If we find phi 12 from the last formula, I didn't discuss the general formula there. Let me discuss the general formula. The general formula here would be, let me write it with a red pen. Okay. General formula here would be 5 into n, which is in the form of e to the power p, b to the power q, and c to the power r, will have, uh, oh, no, this is n e to the power p, b to the power q, and c to the power r. Okay, let's move ahead. n to the power, okay, what will be phi n? Phi n would be, phi n will be a into e to the power p into b to the power q into c to the power r, 1 minus 1 upon p, 1 minus 1 upon b, 1 minus 1 upon c. This is the general formula. So let's move ahead and apply the general formula of phi 12. Phi 12 will include uh, 12 into 12 into, this is a number which has two prime factors, that will be 1 minus 1 upon 2 and 1 minus 1 upon 3. Great. Now this can be written as 12 into 1 upon 2 and 12 into 2 upon 3. So that will give us four prime factors below. We have proved that. Okay. And what will be the sum of these numbers? The sum will come as 12 upon 2, that is n upon 2 into phi n, that is phi n is here 4. 12 upon 2, 6 into 4 is equals to 24. Now we can see that 18 plus 6 is 24. The sum of these numbers will be 24. So we have got a general formula. I will use another color here. Let's use the red color here. The general formula of sum of co-prime numbers. Sum of co-prime numbers that are less than n would be equal to n upon 2 into phi n. Right? Now, why the sum was 4 into 6? Okay. We are noticing that 5 and 1 comes out to be 6 and 7 and 11 comes out to be 6 into 3. So that gives us four numbers of 6. That means 4, the middle number will come as, this is 6 into 1 and this is 6 into 3. So as long as we would increment here, let me use another color. As long as we would increment here, as long as we increment here, we will keep on incrementing. Let me write something. Okay. As we keep on increasing, we will be using what? 6 into 1, 6 into 3, 6 into something else, 5. That will be an odd multiple of this. If we take, you can choose it, you can have a look at it. If you take a greater number, it will be that way. So what are we getting here? We have been getting here that these two numbers were to be included. So this will be 6 into 6 into 6 into 6 into 4. It is 24. That's it. Hence, the formula, this formula, general formula, phi n was written as this. Hence, this is true. So, this is how we go by observing the terms, how they are relating to the numbers, and getting the formula out of it. You will have its implementation in some of the formulas, finding some of the formulas, general formulas of algebra. This is how the formulas are found. If even if it's Ramanujan, even if it's someone else like the scientist of highest order of NASA will find it like this. There is no other method of numbers which can be employed other than some higher mathematics. This is basic 10th grade mathematics. So this is how formulas are found. So hope you will remember these formulas, and I will be back with SCF and LCM concepts next time with all the explanations. Thank you for watching the video.